Hello, we are Team XPosure, a group of Tulane biomedical engineering seniors. This year, we were working to help provide X-ray solutions for low-resource setting communities. Our group members consist of Deepika, the CEO, Marco, the CFO, Tim, the COO, and Marcos, the chairman.
Medical imaging is crucial at all levels of healthcare, with more than 3.6 billion procedures being performed annually across the world. With improved healthcare policy and increasing availability of medical equipment, the number of global imaging-based procedures is increasing considerably.
Protection from X-rays is important since radiation can induce cell killing and non-lethal transformation, which could lead to cancer. Radiation safety is particularly important for medical staff who perform thousands of procedures every year. Some procedures involving fluoroscopy, including orthopedic surgeries, can last up to 6 hours, which result in prolonged exposure for the doctors and nurses.
Lead is the cheapest and most commonly used material for radiation protection. It can effectively attenuate X-rays because of its high density and atomic number. Lead vests are the most commonly worn protective gear since it covers the person's torso, the part most vulnerable to radiation. However, these lead vests cost between $500 and $1,000 and are also easily damaged if not maintained properly. In addition, they are very heavy and can be uncomfortable for their wearer for long periods of time.
A lot of hospitals in low-resource settings cannot afford to spend the thousands of dollars purchasing multiple lead vests, and thus they only hold a few. This causes a restriction on the number of staff members who can safely be present in an operating room while imaging is being done, causing procedures and wait times to be longer than necessary. Therefore, our need statement is that doctors and nurses in low-resource settings need an affordable method of protecting themselves from X-rays in the operating room so that the number of lead vests required is minimized.
We are lucky to have partnered with RadAid for our service learning. They are an organization focused on improving radiology infrastructure in the developing world, which aligns very closely with our goals. We worked with RadAid's Granada branch, developing documents such as a research proposal template and radiation safety committee details for the country's Ministry of Health.
By attending their annual conference in Washington, D.C., we were able to get feedback and advice for our project from radiologists with experience working in the developing world.
An existing alternative to lead vests is lead barriers for shields. These can be placed beside the operating room table, protecting everyone standing behind it from scattered radiation coming from the patient. However, there is an issue with shields. Shields pose the problem that they are either too high, that they obstruct the procedure, or too low and don't provide enough protection. We wanted to find a solution to solve this issue.
Throughout our design process, creating physical and computer prototypes to visualize our different iterations was very important. We purchased several materials such as hinges, magnets, and wheels to make our prototypes. Many of the prototypes made were designed to test individual applications of our design.
Our first prototype had a shield that would attach to the side of the table. However, we moved away from that idea, deciding it would be better if it had its own stand with wheels so that it was more mobile.
After talks with our academic mentor, Dr. Brown, and our industry mentors, Dr. K and Dr. Knapp, we came up with the idea of the shield having panels that could open and close to allow the physician to work through it. We laser cut this prototype in our makerspace to get a feel for the idea. This idea was inspired by the sliding puzzle game.
Our next prototype included having lead-lined glass in the topmost portion of the panel. This allows the surgeon to view the patient comfortably while still being protected.
We also prototyped how the panels would open and close. We decided on adding push-to-open buttons behind each panel to make opening easy and magnets so that the panel won't move out of place. This is similar to the mechanism in modern kitchen drawers.
For our most recent prototype, we only spent $16 manufacturing it. We use spare plastic and the water jet cutter in our makerspace. This shows that a low-fidelity version of our device can be made very cheaply. However, we did not include the lead-lined glass.
Due to unfortunate circumstances, we can no longer work in person on the physical prototypes, so the final iterations and proofs were done in a variety of softwares. This CAD model was altered to approximately show how this device would be set up and interact with in an operating room. The final iteration would have a curved surface, allowing for ease of execution of the surgery. We had planned to test our device in a radiology room at Oshner, using a water phantom to mimic the patient and dosimeters to test the scatter radiation received in different locations of the room with and without our shield. We were unable to perform this. However, we calculated a simulation to predict the exposure.
We used a Monte Carlo sampling function, which simulated thousands of photons propagating through air and lead mediums to determine the effectiveness of our prototypes.
The exposure shield will likely fall under code NAICS 621512. This is a device to be added on the fluoroscopy machine or fluoroscopy table. Many big-name manufacturers are involved in the X-ray industry. However, protection is left to smaller, individual companies, often contracted by hospitals. Based on the materials used and dimensions of our shield, the projected cost lies between $423 and $824, largely depending on the cost of the lead-lined glass. This does not exceed the cost of one lead vest and protects multiple people in the operating room as opposed to just one.
Therefore, the shield allows more staff members to safely help with surgeries involving imaging, without the hospital having to purchase multiple lead vests. Based on our feedback from experts, physicians will be more likely to use it since they don't have to wear heavy apparel and it also doesn't obstruct them from the procedure.
Thanks for watching!